Hello, good evening. Good evening, Engineering Dennis, Engineering Abdul, Engineering Abdul Rizwan.
Good evening, Dr. Sam.
Welcome for all. Let's start. Okay. So today we will talk about four new topic. The topic today is heat transfer, and one is related for this one application for HVAC. So we have more information today. Let's see. At the beginning, why you study heat transfer, or with another way of the question, what is different between thermodynamics, which is covered before, and heat transfer topic? Does you have a difference between these two? As you know, thermodynamic, we have in first law of thermodynamics, it is heat. The change of internal energy, it is equal heat plus work. So we can calculate heat by first law of thermodynamics. Also, it is including for second law, entropy. It depends on the heat. So why we study another topic, heat transfer? Heat transfer give us what else? Anyone you know? Okay. Actually, thermodynamics, it can give you the amount of heat. The amount of heat. Which is mean energy. This amount of heat can transfer from this point to this point. So you talk about for energy. But heat transfer topic mainly he study the term of heat in the thermodynamic but in more details to know one important thing. What is the rate of this heat? What is the rate of this heat? Not the amount of the heat, the rate of the transfer heat. The rate of the transfer. So the main factor here is time. The main factor here is what? Time. He studied time. Okay? He studied this heat is energy per unit time. What happened with time? Okay? So in this topic, we will cover all parameters related to these factors. Let's start for heat transfer.
Good evening, Dr. Sami. I'm just. How many slides went before?
This is the second slide. This first one, the second one.
Oh, okay. Because I joined class. Unfortunately, my account logged
No
off.
problem. This is just what we discussed now. So what is heat? Heat is energy in the process of being transferred from one object to another due to temperature difference. We study this definition exactly in thermodynamics. So till now, we don't have change. So what is the change? The change we will see now. As I tell you, the energy transfer depend on what? So let's see. First, the energy transfer, it's happened with three different types. These three different types is conduction, convection, and radiation. Okay, this is the three modes of heat transfer: conduction, convection, and radiation. Normally, the three types happen almost in all applications. Almost, not exactly, but almost in all applications. But one of these is dominant for the application. Sometimes three is dominant, but normally also one of these is dominant for this effect. What I mean, let's see example. This one. This example just to bring it here for conduction example. But what I see, the part for convection and radiation is already happening here. But maybe in a small effect. The major effect for one type, which is conduction. So this one, what is the type for it? Heat transfer here, we can mention this conduction. But actually, the other two not happen? No, it is happen, but with this small amount. Small amount. So as per definition here for conduction, conduction transfer of heat from molecule to molecule within a substance. Molecule to molecule, okay, molecule to molecule within a substance. So one of the important things to be contact. One of the important things to be what? Contact, correct? Okay. So the heat transfer here is coming from the contact between flame to stick and to stick to hand. So you feel heat due to contact your hand in the stick, and this stick have heat. So the heat transfer by molecules contact, so this by conduction. But actually, when we know the definition for convection, convection is coming from the movement of the flow. Movement of the flow due to that different temperature for the areas of the gases or the fluid. So according to this different temperature, it create different densities. So it's what happened? Circulations for this flow. So the near area here, it is hot. The far area here, it's cold. So after this hot happen, the what is coming? Circulation between the hot layers here and cold layer here. Cold layer is going up, hot layer going down, and they make it circulation all the time. So according to these circulations, maybe some of the air hot going to touch your hand. So the air hot here make a convection because this movement between your hand and flow gas, air. So convection happen here, yes, but with a small amount, small effect. Also radiation. Radiation, it depends on the object, what is the percentage of viewing the source of the heat. So your hand actually it is sees a flame for the candle. So we have some radiation from this flame to your hand, but still these two it is minor. But the major here, conduction. So we can set for this type of the transfer here is by conduction. Actually, I tell you now the definition for the three types and apply for one application. Okay? Conductivity. What is conductivity? Actually, the conductivity is measured how efficiently substance transfer heat between molecules. Again, how efficiently substance transfer heat between molecules. So this defines this material is bad conductive or good conductive to the heat transfer. So the conductivity is a property for the material, property for the material, and it depends on the molecules contact. So when the bond is near together, which is bonded strong, so this one high conductive, good heat transfer. So this one conductivity here is good. But for air, for example, it is far. So this bad conductor here. But the definition again, this is how efficiently substance transfer heat between molecules. As you see here, the summary for the solid, for example, molecules are strong bonded, high conductivity, liquid is medium, and the gas is low conductivity. Okay. Here's this table just to show you some values for this. As you see, air is one of the poor conductive material. So normally we use air as a isolation material. We can put, for example, between two glasses, a gap is air. Building material between the block and block, we can make inside air, or the block structure itself have air inside to make something as an insulation material. And if you're going down, we can see the iron, silver, and we have another table, I think, maybe some slides you can see. Some of material, if we study all material is metal, we will study the range of which is always good conductor, but which is higher conductor more than the other, and so on. Okay. Heat capacity. This definition very important and critical. Okay. And please be careful about this one and the conductivity of the material. Heat capacity, it is ratio of the amount of heat energy absorbed by that substance to its temperature rise, which is measure amount of heat. We can define by another way the amount of heat needed or added for substance. We can mention for this for 1 unit of the mass, but not fixed certain temperature, not like specific heat capacity. We have a small thing between difference between heat capacity and the specific heat capacity. The specific heat capacity, the same define of heat capacity, but at the end we have small difference. At the beginning, both is amount of heat needed to raise the temperature for 1 gram. What is next? This is the difference between these two. If we fix the temperature rise needed to measure, which is for specific heat capacity 1 degree C, 1 degree C is only 1 degree C, so it is constant. So I measure for all substance amount of heat required to raise the temperature for 1 gram 1 degree C. So I apply the same thing for all materials to raise 1 degree C. So this one considered as a property for the material, same like thermal conductivity. Okay, but heat capacity as a general, no. This just measure according to what is the range of temperature you require. What I mean, amount of heat needed, for example, to raise a temperature of 1 gram of the substance, 5 degrees C. Here, 7 degrees C. There is 10 degrees C. Okay, so it is not property. It depends on your case. Just we can study the heat capacity, which is mean ratio of heat, amount of heat energy absorbed for this substance due to temperature rise, due to temperature rise. So again, the property is specific heat capacity, not heat capacity, specific heat capacity. So we have two properties here going to compete together, specific heat capacity and thermal conductivity. Why I focus for this two a lot? Because the question is coming not clear for this part. What I mean, for thermal conductivity, this study material good or bad conductor, but for heat, but specific heat capacity, it measure what is the response for add or remove heat. What I mean, for example, as he mentioned here, we have two cases: low specific heat, high specific heat. For the low specific heat, if the material have low specific heat, so the heat and the cool for this material quickly. It means it is heated quickly and cooling quickly. Not take time to response for the heat. The response of heat, it is high. So is heat quickly, heat up quickly, and cool down quickly. But if the material have high specific heat, the heating or cooling slowly. It is not depend on the material. It is good conductor or not. This is totally different. So during asking questions, be careful here. Talk about for thermal conductivity or specific heat. Okay, nice. Here, for example, just a sample for some values of specific heat. For example, here, the air is here in the middle, okay? And the higher is water, for example. What is this? Specific heat. Specific heat. Second type for the heat transfer is heat transfer by convection, by convection. And I tell you this one as a definition: convection, transfer of heat by the mass movement of fluid or gas, like water with air. Warm part of the fluid raises, cold part sink. Hot parts raises and cold parts sink, and so on. Going to make this equation all the time. Okay. This one of the application also for convection in normal atmosphere. Also the same process happen. Air is cold, warm air is going up and cold air is going down. Same concept for heat convection. This is a source of for heat. What happened for this liquid? First, this is going to be hot, so going to be hot, going up, and cold going down, and so continue for this process. And also the air outside is heated because the heat part of the heat liquid heated going up, so make a circulation again between the liquid here contact with this surface for the water to heat up and going up, and the cooling air going down, and so on. Circulation up, circulation down. Latent heat, what is the means of latent heat? Latent heat, this is the energy required to change matter from one state to another. This one is energy required to change the matter from one state to another. Okay, it's not, it is different than sensible. Sensible, no, this energy required to increase the temperature. Energy required to increase the temperature of the matter. So it's totally different. One to change phase, one to increase the temperature. Just some examples for what we discussed. Here, heat energy taken from environment and the heat energy released to environment for the type of the liquid water. So if we study the behavior of the water from the solid state to gas state, what we will see? We will see at the solid is ice, at liquid is water liquid, at gas state is vapor. So to going from the solid to liquid, we make processes melting. From liquid to vapor is evaporation. And when you get back from vapor to liquid is condensation, liquid to ice is freezing. So here, from ice to vapor, we need source of heat, correct? But as mentioned here, this considered as cooling process. You tell me that's wrong. No. Cooling process here, it is mentioned to the environment because this one is heat energy taken from the environment and put it twice to change it from ice to vapor. So this process related to the environment is cooling process. On the other hand, we're going to vapor to ice. We need freezing and some cooling. But in the front side for the environment, the heat energy released to environment. So this warming process. Warming process. If we check the phase change for the melting, which is mentioned for this one, is latent heat of fusion. We will found the value is 3C5. But the other one, latent heat of evaporation from liquid to gas, this 2500. So the total latent heat is equal what? Total latent heat is just direct summation, latent heat of fusion plus latent heat of vaporization. But just here also see the range between the latent heat required from the solid to liquid and the latent heat required from the liquid to gas. It's far to change from liquid to gases. Clear? 8 times, something like this. This is the total latent heat for sublimation, which is latent heat of fusion plus latent heat of evaporation. Talk about again for the meaning of latent heat. Okay, kindly start for reading the question. All read the question. Talk about for two material, wood and metal. But you feel in the metal side colder than wood. Why? Actually, as you know, conductor it is have a good conductivity for the material. Wood it is have low conductivity, so the wood is an insulator. And metal conducts the heat away from your hand. You absorb the energy in your hand. So if I remove energy from your hand, what you feel? Energy in your hand decrease. So what you feel? Some cooler, some cooler. But the wood is working as insulator. You don't feel anything. You don't contact with your hand. Clear? So in the case for the material, it is absorb some energy from your hand. So this one, you feel it what? You feel it more colder. But other one, it is insulator, which is not response for anything related for your hand. Here talk about for the particles, what happened for the particles from liquid to gases, and the particle is going to be more far than less dense. Here, this talk about for the freezer compartment, which is put up now. For the previous design, for the regular design, default one. Maybe I know the updated designs now is different, but the main concept, is put the freezer compartment above to make circulation for refrigerant like this. The hot going from down to up, and then going from up to down according to this circulation. It is a better way for routing of the refrigerant. The third type now is what? Radiation. This is the third type. So the radiation here, no particles between the two objects is required. Again, there is no particles between the objects required, because no particles transfer due to radiation type, same like sun and earth. Radiation from the sun to the earth, that's it. So what is his name for this one? Radiation. Here radiation travels in straight line. Radiation travels in straight line. True or false? Let's see the answer here. Okay, true. Radiation can travel through a vacuum. This is solved already. Yes, true. Radiation requires particles to travel. False, false. Okay. Radiation travels at the speed of light. Great. True. This one example. To study the emission, we have 4 containers. I can draw this one here. These 4 containers, in each one have a warm this warm water. So which container would have the warmest water after 10 minutes? Again, which container would have the warmest water after 10 minutes? We have shiny metal, dull black, shiny black. So what we see? Dull black, shiny black. Mm, Okay, we have different here, dull black, shiny black, shiny metal, shiny dull black, shiny metal, shiny metal, shiny metal. Okay, For what? For which one? First one or second one? Actually, if we study carefully, the source of heat here, this is the source of heat.
Doctor, we are not seeing you.
Okay. Yes. Wow. Emission of shiny metal is emission very less. Okay. Hey, let's see first here. This is a source of heat, correct? So which container would be the warmest after 10 minutes? The warmest one actually
Which
is
one is source of heat?
what?
Which one is source of heat?
The warmest one is shiny metal. This one. Why? Shiny metal is reflected from the outside surface anything coming, and also the inside is reflect. Energy inside going to go out, reflect, going to go out, reflect. So container would be the warmest after 10 minutes because its shiny surface reflect heat radiation, reflect heat radiation. Okay, back into the container again, so less is lost. The loss of energy from inside is lost. All energy try to go out, keep it in this, keep it on the same. So the
Sir, can
which
you
one? The other one is the dull black. The dull black is container would be the coolest because it is the best at emitting heat radiation. The best at emitting heat radiation. For dull black is emit all energy inside. Emit, emit, emit. So the energy inside decrease. Clear? Similar to this question, let's see this one. These two different questions. Here, the four material with equidistance from the source of heat, all the same distance from the source of heat. So which container warmest after 10 minutes? That black. This is the warmest one. Why? Because surface absorbs heat. Surface absorbs heat. Radiation the best. What do you mean? For dull black, if the source of heat inside is emit everything, so this one is the coolest one. But for absorption heat from inside outside, so it's collect all anything coming is collected. So this one is absorbed due to absorption for uh, energy. So this one is the dull black, it is the warmest one. But other side, the shiny metal is the container would be the coolest. Why? Because the source of heat outside, and this source of heat going cross the boundary. So due to crossing not happen. Why? Because this one is a surface highly reflected, so all energy reflected. So the metal shiny is reflect energy, and due to that, it will be the coolest one. It will be the coolest one. So the shiny metal container would be the coolest because it is the poorest at absorption heat radiation. Is the poorest for absorption heat radiation. Why does hot air raise and cold air sink? This is what we discussed. Because cold air is more dense than warm air, so the cool air falls through the warm air. Why air boilers placed built hot water tanks in people's homes? Actually, hot water raises, yes, and due to that, the boiler heats the water and converts the water to be hot water, then from hot water to be partially steamed. The hot water raises, the water tank is filled with hot water and have vapor. This increases the pressure inside. So we need to put pen for the hot water boiler. Why are houses painted white in hot countries? Why? This famous in our country, famous in country Doha. You don't know? Because the white houses is what is reflect. The white houses reflect the heat radiation and keep the house cooler, reflect the heat radiation. So this is the main reason to paint the house with white colors. Which of the following is not a method of heat transfer? Which of the following is not a method of heat transfer? Insulation. Transmission of heat by molecule collision is
Conduction.
conduction. Yes, first answer is conduction. It can be done from one place to another place. Conduction, convection, radiation. Okay. Here, just to involve final conclusion. You mentioned conduction and the convection involve particles, but radiation involves electromagnetic wave. Okay. This summary for the conduction, convection, and radiation. So let's see the effects, some effects for some factor affects on the heat or rate of heat transfer. If you study step by step, actually you will see that temperature difference, temperature difference before on the one surface, for example, before the heat is going to be transferred, and the other one after heat transfer. The two surfaces, it means delta T, delta T. One of the main parameter affect, for example, if I give you two cup, this two cup I put in the same environment, but this two cup one change temperature from inside to outside, the temperature is 20. The other one, not 20, 44, 5. So this 45, this 20, so the heat transfer is different. The amount of heat transfer is different. So the temperature difference between the surface, one of the factor affect on heat transfer. What else? What else? Check, check. Yes. Thermal conductivity. The property for the material, but according to this value, we can check the heat transfer rate is high or low. What else? Thickness. If the body or the material is thick, the transfer heat is thick time heat transfer. But if the same material, so the thickness is effect. What else? Area. surface area. You need to transfer heat along the surface area of the cup, or um, another one we can, for example, pain. Okay, the heat transfer due to this one is a long area, so the heat transfer is going to be easier and not take time. Same this one. If you put the tea in this bag or cup and put the tea in another small cup, you will see the difference. This one take time to be cold. This one is not take time. It's less. So we have different parameters for that. We collect all these parameters, all this, and put in one relation. Some of this parameter, it maybe change it from one to another according to the type of the heat transfer itself. Conduction, convection, radiation. For example, for conduction, I would depend on the conductivity. Convection, it depends on the convection coefficient factor, and so on. According to the type, we can change small things, but we have some parameters is including. So different materials have greater or lesser resistance to heat transfer, making them better insulators or better conductors. So let's see one of the questions for this one. First one for conduction. This for conduction, as you see here. This is the equation. What is this one? This Q by time. What is Q? The energy. But here we don't study energy. We study what? Heat transfer. Heat transfer. So we study. This one is Q dot. Heat transfer.